Hey guys, so today we're going to be going over resonance. I decided to do a face cam this time because it's easier for the commentary. And the big thing is why are we doing resonance? So the main reason we do resonance is because it's really big part of Orgo 1, and it's a foundational skill that's going to be required all throughout the course. So the sooner you learn how to do this, the easier the course is going to be as a whole. Write that down for you guys real quick. I had this pre-recorded, so I wrote everything out, and I'm just putting the face cam on, so it might be a bit delayed, but work with me. I just want to see how it works out. But if I don't like how it works out, I'll probably just go back to the old way of doing it. So let's begin. First thing you should really know is your periodic trends. I'm going to go over that here right in about like a minute or two. I'm going to show you how to utilize the periodic table, the organic periodic table, not the general chemistry periodic table. So many of you are probably new to this periodic table. Memorize it, know how many bonds there are, know the trends, what they all mean. I'm going to go over some of the trends that you're going to need for resonance. So the thing you should know is that there's one bond for hydrogen, lithium, sodium, potassium. Then it goes 3, 4, 5, 6, 7. I'm in electrons, not bonds. And that's going to be in red. Those are on top. That's the number of electrons that each of these possesses. Okay? Now on the bottom, I'm going to draw in blue the bonds. So 1 for those, 3 for those, 4 for the next, 3 for the next, 2 for the next, and then 1 for the next. And that's how many bonds each of these makes. As you see, I'll write in later that some of this stuff gets crazy, but okay, now this line indicates that anything past this line always follows the octet rule. So that arrow shows it always follows the octet. It has to have 8 electrons. It can't break that rule. So remember that, because it's going to serve you big in resonance. Because some stuff you're going to want to be like, oh, I'm going to move this charge, I'm going to move it over here. But don't, because if you break the octet, it's wrong, and it's not a good compound. And of course, this is for our purposes, because some of that stuff, fluoride, chlorine, bromo, iodine, all that stuff, it can do some really crazy stuff that you're going to learn about in organic chemistry 2, but you're not going to learn about that in organic chemistry 1, so don't worry about that. Here I'm just going on about resonance again. Resonance shows how electrons move throughout a compound, and it's not step-by-step fashion. I mean, we draw it in step-by-step fashion, but this all happens at the same exact period in time. All of these arrows are happening simultaneously at the same time. Remember that. It's not a step-by-step fashion. For our purpose, we can't draw it all at the same time because our brain doesn't computate that, but for our reason, we're going to draw it step-by-step, but remember that it all happens at the same time. It's not a step-by-step fashion, how we just draw in a step-by-step fashion. Okay, so you're going to use these little things called resonance arrows. I have those drawn in red, and then the black dots are your electrons. And you move the electrons, or pi bonds, which are your lines across the other bonds, double bonds or your pi bonds. So then show that you can move either the pi bonds or the electrons with the resonance arrow, which I have highlighted right here. And I'm going to show you some examples and everything, but I'm just kind of showing you the basics before we get into it. Here's a really simple example where we're going to have a positive charge on the left, and then we're going to resonate this pi bond over the left, and then put that positive charge on the right. Just like that. That's a simple example. You should be able to do this in your head. I hope you don't have to actually draw that out. It's not even really a relevant resonance structure. Carbon to carbon is not a very relevant resonance structure. You want heteroatoms like oxygen, nitrogen. Those are your most relevant resonance structures. But let's dive into some practice problems. This is where the big bad boys come out, the ones that are going to be most useful for you guys. And there's some more stuff I wrote down. I'm going to quote for you guys, because resonance is basically, it's the first thing you're going to learn in Organic Chemistry 1. It's the simplest thing you're going to learn. And I think experience outranks everything. So if you learn this skill, you're already setting yourself up for success. If you blow this skill off, you're already setting yourself up for failure. So let's set ourselves up for success, guys. This is the quote to live by. Experience outranks everything. Great quote. Okay. Let's get into practice problems. Come on. Drawing it out. So I should also tell you that the first thing you want to know is that the charge has to remain constant. So if it's a neutral particle, it has to, or a neutral compound, it has to remain neutral. No matter how you move the electrons, it has to remain neutral. We can't create charges. I can't just put a random negative charge on there and make it a negatively charged compound. It has, if it's neutral at first, we have to do resonance that shows that this compound is still neutral. For example, if I resonate this pi bond up that oxygen, it's going to be a negative charge on the oxygen, a positive charge on the carbon. It cancels out and that gives us a neutral compound. Remember that. It's a very important rule. I'll show you right here. And then we're going to resonate these two electrons from that nitrogen over onto that positively charged carbon, and it's going to give us a positive charge on the nitrogen, which is then going to give us a neutral compound once again. And always, always, always show your resonance arrows going back to the original product. Drawing this out for you guys to show you what it looks like. Follow along. Okay, so you're going to resonate that. It's 2 electrons over. It's remaining constant. Boom, bada bing, negative charge on the oxygen. NH2, positive charge on the nitrogen. Resonate up to the oxygen. Go back to normal compound. Well, not the normal, the original compound. Also, don't ever draw the pi bond going onto that positive charge. I mean, it's not wrong, but it just doesn't look professional. We want to look professional. We want to do everything to the best of our abilities. Draw it going onto the actual where you want it to go. Those arrows should show exactly where those electrons are moving. They're not moving to that positive charge. It's actually moving on to that atom, the nitrogen atom. And there you go. There's example 1. Let's move on to example 2. After I label this, example 1. Also, I recommend you guys go back, draw the original product, and see if you can do this on your own. That's the best way to practice this stuff. Here's example 2. And this one's already going to have a charge on it, a negative charge. So that means we have to make this compound remain negatively charged throughout our resonance. We can't add positive charge or make it neutral. We have to make sure that it always has a negative charge on it. Because it's originally a negatively charged compound, so we got to keep it a negatively charged compound. And I'll show you here. If I can draw properly. Come on, Barnett. Get your head in the game, brother. Okay, there you go. So negatively charged compound, we're going to resonate up to the oxygen, make the oxygen negatively charged, and we're going to resonate those excess electrons over, creating a pi bond, which will get rid of that neutral, that positive carbon from the resonated oxygen, and there you go. You have the negative oxygen on top, and then you have the pi bond right there, making it an overall negatively charged compound once again. Then show the resonance going back to the original compound. Boom, bada bing. It's your final product. It's as simple as that, guys. It's not a hard skill, but it is definitely an important skill. You're going to need this all throughout because this definitely goes into stability, pKs, pH, all that kind of stuff. Knowing which compound's more stable than the other one, because it's using the REO system, atoms, resonance, induction, and orbitals. So you're gonna have to know all that because that's how you're gonna be able to tell which compound's more stable. So definitely a skill you're gonna need. This is gonna be the final example. I just want to show you guys you can do this with a positive charge. It's a little bit different, but you can do it. Just remember your periodic trends. It works the exact same. Just remember that you can't break those rules I told you, and the number of bonds, the number of electrons each one possesses. And if it's already positive, we have to keep it positively charged all throughout. If it's already neutral, you gotta keep it neutrally charged all throughout. If it's already negatively charged, you gotta keep it negatively charged all throughout resonance. Okay, so we're going to resonate this pi bond over onto the positively charged nitrogen. That's going to give us positively charged carbon. And then do a step-by-step because we want to show the most resonated structures as possible. As many resonant structures as possible. Blow up, mess up my grammar there. So now then you have a positive charge there. Okay, resonate this pi bond over, and then I'll move the positive charge over onto the carbon. And then we're going to move it over one more time, put the positive charge on the end, and then we're going to resonate everything back to the original compound. And it's as easy as that, guys. Not supposed to be hard. This is the simplest stuff you're going to learn in orgo. And there you go. That's how you resonate stuff. So thank you very much for watching today. I hope this helped you all. Good luck this semester. I'm probably going to drop some more videos on just some basic stuff, anything you guys need. Yeah. Good luck out there, soldiers. Not an easy class, but work hard. You should get through it.